Hello, everyone. Thank you for coming to Speech and the Language Technologies Meetup group. And this is our weekly paper sharing session. Today, I will try to share a paper W2v-BERT combining contrastive learning and masked language modeling for self-supervised speech pre-training. And this work is by Chang Yuan and his mentor and colleagues while he was doing his internship at Google Brain. And this guy is from MIT. By the way, this event is sponsored by Olawig Inc. W2v-BERT, as mentioned by the author, it can be optimized in an end-to-end fashion by solving the two self-supervised tasks, the contrastive task and MLM simultaneously. I think especially they added the MLM on top of the contrastive loss is novel. What they From the name of the proposed method, you can definitely see this is a combination of Wave2Vec, actually 2.0, with the BERT. And the whole purpose of these W2v-BERT is try to um, obtain inventory of a finite set of discretized speech units. You may ask, wait, what does the speech units mean here? Do you mean the phonemes or the phones in English? Actually, not. Um, the unit might be even smaller than the concept of a phone. Um, well, imagine this. Suppose you do not know a language and you're asked to cluster the sound you hear from that language or spoken language into n clusters. Okay, so after you do the clustering, uh, all the samples that are being clustered into a single cluster is called a speech unit. Okay. And this concept before the pre-training or unsupervised training um, has been proposed in some low resource languages. For example, suppose you want to recognize some Tamil, the Southeast Asia spoken language, you probably don't have any solid transcription of it. Basically, what people are doing it was to cluster the sound from that language into acoustic units, and they consider that acoustic unit to be phones. Then they start from there and try to uh, define the language, define the speech modeling process. And nowadays, when this pre-training or unsupervised learning is being introduced, the speech unit is being used to model I would like to call it a feature space, a space you can discretize or quantize your speech signal. So uh, after you do the quantization, you can do unsupervised learning on top of that. Okay, questions already? And of course, the author mentioned that okay, definitely there are two things you want to do for this nowadays large scale or the model which uses a large amount of data for training. The first thing I think I think they should reverse the order. The first thing is unsupervised pre-training, like we just talked about. The another thing is called self-training. For those of you who are not familiar with self-training, you can search the big SSL paper by Google or search the big SSL keywords in our channel. I have a 1 hour tutorial on this. And FYI, if you're not familiar with certain terms, you can definitely search the term in my channel. You can probably find the quick tutorial I recorded before. Okay, so what they do in this new proposed method, I assume that you are familiar with Wave2Vac 2.0. So once you see the figure number 1, so you can definitely tell that, okay, the lower bottom of the figure is the block or the method that is being used or proposed by Wave2Vac 2.0. Okay. Um, on the on the left side, you have this feed forward loop, okay, and passing through their conformer blocks. For those of you who are not familiar with the conformer, just search your conformer paper, okay. Um, I would use a one sentence which might be inaccurate to describe the conformer. So conformer, in my understanding, is remember the self-attention networks that is being used in transformer or BERT. They add a convolutional module after the self-attention, but it's more complicated than that. But I think it's safe to assume that this is being in this way. And you can see in the Wave2Vac on the left side, the context vector is being sent to the contrastive loss calculation. And on the right side, after you encoded the feature after this output of the convolutional networks, you can run quantization on top of the encoded features. Quantization. So you may ask, wait, what is that? So in the Wave2Vac, they use a very dedicated way of doing the quantization. They leverage a softmax called a Gumbel softmax, so which made the quantization to be or could be differentiable, which is very nice because you can see after you do quantization, you get the targeted convex vectors. So these two vectors are being sent into the contrastive loss, right? And you can see afterward, when you calculate the backprop, you can not only update those conformer blocks, linear blocks, using your derivatives or partial derivatives, you can also update your quantization modules parameters because you define the differentiable softmax for the quantization. Okay, so this is fundamentals of Wave2Vac. But what the author proposed the new stuff is they add a few more conformer blocks on top of the existing feed-forward networks, and they get another convex vector. Okay, and then also they after the quantization quantize everything using the raw samples, raw features. Instead of getting the target convex vector, they got discretized IDs. So for those of you who are familiar with BERT model or transformer model, so I hope this will recall your memory. Remember, most of the time BERT is being applied or used on top of textual input, okay? Because for the text, you can first tokenize the text, or the text is already token, right? Of course, in the actual BERT training, they use something called a word piece. But if you want to use a word, that is okay. So word is token, word piece is token, but speech is not token unless it has to be quantized. So this is these discrete IDs can be viewed as tokenized speech signal in my understanding, or aka speech units, or this can be the unit ID. Okay, so the author is so smart. So once they get these IDs, he can treat the speech problems as the natural language processing problems. Okay, so he can use the loss that is being used in BERT. Of course, the loss should be CE loss, but in order to distinguish the loss from the contrastive loss, he used this MLM loss. But indeed, he is covering or masking some of the IDs right over here and trying to use the left loop to see if he's able, or the trainer is able to recover these master IDs by minimizing um, the CE loss. Okay, and of course the two losses, you also used here the loss. He in equation number one. He all he did, no, this is the wave 2 back loss. Sorry. So you can see in equation two, they also try to combine these two contrastive loss and MLM loss in a weighted style in equation two. But he said, okay, I don't want to tune this. I just want to set this to be 1 and 1. I think the author did a good job, because you want to see this thing is stable, not working because you fine tuned it or tweak this too much. Very good work. Talking about the results, I would have to say the results are very good, very, very good. Any questions right now? So far, so good? Okay, so the table two shows the ablation studies, or the comparisons of different methods on the Libre speech task, which is 960 hours of training data. But they do get unsupervised database, which is, I think is called Libre Lite, which is 60K hours of unlabeled data. See right here. Okay. And once they train from scratches, because they're Google guys, conformer is invented by those Google guys. They always use a conformer. Okay. So when you start from scratches, you don't use the label data. They get a baseline of 2.1, which is very good. With LM is 1.9. Okay. And then they do the self-training. Okay. What does the self-training mean? Okay. Self-training means once I get the trained model from scratch, and now I have unlabeled data. I have 60 hours on labeled data. So NAST means noisy student training or self-training. They're the same thing. If you find a Google paper, they're talking about self-training or NAST, they're the same thing. What they did was they used the model training from scratch to recognize the characters or the words in the unlabeled data. So they get this type of label, actually, right? Text label. They call that pseudo label. And it's not actually as good as human being transcription, I think. But according to the results, even they're using these pseudo labels or recognition results, they're capable of further reduce the water error rate by 0.2%, which is very significant. And then the pre-training only means that using the pre-trained model as a feature extraction module before the encoder, okay? Or they lay the encoder on top of their pre-trained model, okay? They compare these things, Wave2v-BERT. I think I'm always interested in, I think this confused me lately, whether Hubert is better or whether the Wave2v 2.0 is better. Um, According to Google's results, I think if you look at the results, uh, when the model size are the same, um, Wave2v is slightly better, but not too much different. Of course, this when the Hubert X large, they increase the size of it. Uh, Seems that the model did get better for test other. And then if you see the fourth line, uh, they switch to the conformer, okay? Especially when you see the fifth line, I think this size is similar as the Hubert X large, okay? Then you can see the Google guys get 1.5 and Hubert X large is 1.8. Definitely better. It's better than the Hubert. And what the thing is that Hubert doesn't use conformer, and we all know that conformer can give you a gain. So it's really a question to me whether the gain is brought by conformer or switching the Hubert to Wave2v 2.0. And then this is their proposed method, W2v-BERT. Okay, this is adding a extra M2M loss on top of the W2v conformer, and you can see um, when there's no language model, they can get about 0.1, 0.2% significant amount of gain, and with them on the clean test, no difference. And on test other, they do have perceived significant gains. And also they try the self-training. Self-training result is very good, I would say. It's interesting to see that with the unlabeled data, doing the self-training can further improve. Even the WER is already very low, 1.5. They can further lower that down to 1.4. I do have some suggestion for the author if he can see the video or somebody can tell can tell him. First of all, you shouldn't call the end-to-end model as AM because this confuses people. AM is usually talking about the model that transduce speech or MFCC features into CNONs or tied states in HMM or tied states of HMM model. I think it's better to say this is end-to-end model. The second thing is I think it's time for researchers to report 1.xx other than 1.x on the Libre speech data because 1.4, 1.45 and 1.40 are roughly the same, are the same in your case, but they may show some difference. Any questions?
Sorry, what is AM short for?
Yes, it's called acoustic model. See here.
Oh, I see.
I think this is a model which was still popular right now and was very popular 10 years ago. Definitely 10 years ago it was the state of art, but nowadays it's gradually being replaced by the newer concept end-to-end model. Usually the Kusi model, like I mentioned, is about um, how to train a network or model that can convert the feature to speech units, for example, tied states in HML. But for the end-to-end model, everything was modeled in a holistic way, right? So the input is a speech feature or a speech sample. The output is the final speech transcription or the text. So you see the difference, right?
Yeah, I see. Thanks.
Okay, I will stop here.